Hey everyone, this is Asif Mehboob, and today we're diving into how we can revolutionize legacy systems with the power of .Net and microservices, thereby transforming your rigid, monolithic architectures into an agile and more scalable ecosystem. Now, legacy systems, although reliable, they bring with them a lot of complexity and are often inflexible. With the capabilities of a modern framework like .Net, we can redesign these systems without needing a complete rebuild from scratch. By using microservices, we break down these legacy systems, also sometimes known as monoliths, into smaller, more independent, and more manageable chunks that allow for scalability and adaptability, depending upon the changing needs of your business. Now, using microservices not only enhances your application's agility, which is the speed with which your code can adapt to your changing business needs, but it also provides a certain degree of future proofing into your applications. You get faster deployments, you get quicker turnarounds, you get better fault isolation, and essentially more efficient use of resources with this approach. So in the next few minutes, we'll explore how .NET and microservices work together and transform legacy systems and why this transformation is essential for your organization. So let's get started. In my experience, legacy systems present major challenges for organizations. They act as roadblocks to innovation, they slow down growth, and they prevent development of new features. Now, over time, the cost of maintaining these outdated systems also rises, and the specialized expertise that you need to support them becomes harder and more expensive to find. Now, beyond operational concerns, legacy systems also pose serious security risks. Since they lack all of these modern protections, so that leaves the organization vulnerable to compliance issues and cyber threats. So if we want to remain competitive, we must address these challenges head on. Modernizing our technology is not just an IT initiative anymore, it's actually a business necessity. So let's take a small example to illustrate the challenges and issues with legacy systems and this monolithic architecture, right? Now let's consider this video that I'm currently recording. Let's say I recorded this entire session in a single continuous recording, and then I need to apply some effects between each slide. So I write a script that will apply certain effects at certain timings in this video. And on post review, I decide that slide number X and slide number Y need to be updated, and I need to record them again. So since this is a continuous session, I would either have to redo my entire session, or I would have to use certain complicated tools to replace these parts of these videos. So then I would have to rewrite the timings on my script, and all subsequent timings would also need to be adjusted. So you see how a small change easily snowballs into this massive effort. On the other hand, if I were to record this session as one video per slide, and later just merge all the videos, making edits to individual sessions would just be as easy as re-recording that particular slide video and then merging them all over again. My script would not have to be reworked because each script would be built to be run at the end of a particular slide, and the timing of the slides would have no effect as to when the script ran. Now, of course, this is a very simplistic way of looking at this whole thing, but I hope this gives you an idea of how monolithic systems differ from these microservices-based architecture. Like I said, modernizing your system is no longer optional. It's actually a strategic necessity. The key drivers are clear: better user experience, reduced costs, enhanced security, and improved scalability. Now, intuitive and user-friendly interfaces are essential to provide a good user experience and improve productivity. At the same time, modernization reduces maintenance and operational expenses. It delivers significant cost savings. And with the ever-growing cyber threats, modern security measures are all the more important to protect your sensitive data and ensuring compliance. As your organization grows, your scalable systems will allow you to expand without compromising performance. And by embracing modernization, organizations position themselves for long-term success. They offer better user experiences, they lower costs, they strengthen security, and they prepare for future growth. Now, the .NET platform has undergone significant evolution over the years. It began with the .NET framework, which was a Windows-only platform that offered rich libraries and services. This was then followed by .NET Core, which was an open-source cross-platform version, which was designed for better performance. And then starting with .NET 5, and as of today, I think it's .NET 9, the latest version of .NET, Microsoft unified these two worlds. So .NET now combines the robustness of .NET framework and also the flexibility and speed of .NET Core. So this timeline visually highlights the key milestones in the journey of the .NET platform. So here are some benefits that we saw at our organization by moving to this new architecture. We now have a 24/7 development cycle with continuous operations across 3 shifts. So this ensures that our software is constantly evolving and improving. Modernizing our .NET infrastructure has also accelerated our development speed by 67%. This allows us to deliver new features faster than ever. Also, by optimizing our computing resources, we've increased efficiency by 40%, and this enables us to achieve more while using fewer resources. So, what are microservices? Microservices are essentially small, independent services that collaborate to deliver specific business functions. Each microservice performs one and only one business function. Now, unlike monolithic architectures, microservices are decoupled. This means that microservices can be independently developed and deployed. The key characteristics of microservices include being loosely coupled, business-focused, independently deployable, and resilient. Now, this slide offers a high-level introduction to the microservices architectural style, and this is the foundation for the rest of the session. Now, why should we use microservices? Microservices architecture allows us to scale individual components independently. It supports up to 40% annual growth in system capacity, and this design enhances fault isolation. What is fault isolation? If one service fails, the rest of your system remains unaffected. So, greater reliability. It also gives us the flexibility to choose the best tools and technology for each service. This avoids the limitation of this one-size-fits-all approach. So if I want to develop a microservice in .NET because it gives good performance in database week, and develop this other one in Python because it has this one library that performs this particular map function very efficiently and quickly, again. Most importantly, the modular structure allows us to deliver new features and fixes faster, which in turn means faster time to market. Huge advantage in a competitive landscape. Microservices architecture allows teams to deploy new features independently without updating the entire system. It reduces the overhead of coordinating with multiple teams in order to release a new feature or bug fix, and eventually it accelerates development, deployment, and most importantly, innovation. It also supports a fail fast, learn quickly mindset. This allows teams to experiment with new ideas and test them with minimal risk. Moreover, microservices align seamlessly with modern DevOps practices, so think automation and continuous delivery. This boosts agility and helps teams deliver value faster and more efficiently. So, how do we go about modernizing our legacy applications? There are 4 primary approaches, and each of these have varying complexity and impact. The first is rehosting, also known as lift and shift. This simply moves your application to more modern infrastructure and does not alter your code in any shape or form. The next one is refactoring. Now, this improves the internal code quality and structure, but keeps the application's external behavior the same. Then we have re-architecting. Now, this involves more significant structural changes to your code, which then unlocks newer capabilities for your application. And the final one that we have is rebuilding, which involves fully recreating the application with modern technologies and approaches. Now, of course, each of these methods offers distinct benefits for your organization, and it all depends on your goals and your resources. To kick off our modernization journey, the first step is a thorough analysis of your current system. We'll begin by identifying key stakeholders. This includes business users, IT teams, and other critical players. This will help us understand the business context and the user needs, which will then allow us to capture the essential requirement. Next, we'll create detailed system architecture diagrams, document all components and the dependencies, and this will allow us to gain a complete picture of the current environment. Finally, we'll assess the system's technical debt, which is evaluating the code quality and identifying performance bottlenecks and anything that requires our attention. A deep understanding of the current state is absolutely essential before we can move forward with our modernization strategy. So, as we embark on this modernization journey, it's essential that we define clear business objectives and success metrics. We need to find the right strategy for each system component. Now, whether that's replatforming, factoring, re-architecting, it all depends on the specific needs and goals of your organization. Detailed roadmap should then be developed. We need to outline the transition steps and the timeline. Finally, we need to secure full stakeholder alignment and ensure we have the necessary resources and support, as that is critical to executing this plan successfully. As monolithic applications grow in complexity, they can become difficult to maintain. So breaking them down into smaller, focused microservices can help solve this problem. The first step in this process is identifying your bounded context. So essentially mapping business domains to distinct contexts and defining clear boundaries. This ensures that each of your service will have a well-defined scope and responsibility. Next, we define the service boundary, which is designing each service around a specific business capability. The aim is to keep the services focused and cohesive. This avoids complexities that can arise from trying to cover too many areas in one or many services. Effective communication between these services is also key. So APIs and messaging patterns are used to define integration points and data flows between services, thus ensuring smooth interactions. Finally, we create service couplets to standardize development processes, enabling consistent implementation across teams working on different microservices. Now, this approach helps us achieve better scalability, better maintainability, and of course, agility in your application development process. By migrating to scalable cloud databases, we can utilize managed services to dynamically expand our data infrastructure as needed. By implementing repositories, ORMs, and data abstraction layers, we will be able to simplify our data access and improve usability. Maintaining data integrity across services and employing eventual consistency strategy is crucial for ensuring that we have consistency in our distributed systems. Lastly, enforcing encryption, strict access controls, and robust data protection measures will greatly strengthen the security of our data layer. Now, implementing a CI/CD pipeline is a key step in automating your software delivery. This ensures a consistent, reliable, and scalable deployment process. So the key components include automated builds that compile your code and then run your unit tests, containerization to package your application and its dependencies, an orchestration platform like Kubernetes to manage and scale your containers, and then a deployment automation with release gates and monitoring. Now, these elements enable fast and confident delivery of your new features and updates. The diagrams on this slide showcase the technical components and flow of a modern CI/CD pipeline. This is all crucial for cloud-native development. The SRE principles are 5 key design guidelines, and they promote maintainable, extensible, and testable software. 2 important design patterns for data access are repository and unit of work patterns. These help organize and manage your application data. Also, you have the factory method and dependency injection patterns, which enhance flexibility and testability. When you're optimizing for the cloud, it's important to focus on auto-scaling, load balancing, caching, and resource optimization. This ensures both performance and cost efficiency. Incorporating these principles and patterns into your refactoring process will lead to improved code quality, improved scalability, and maintainability. Modernizing legacy systems comes with significant challenges. First, there's a skill gap because teams need new training on the new tools and practices, which can then affect productivity as they climb that learning curve. Second, resource allocation. It's important to balance resources across services to prevent performance issues during this transition. Finally, managing distributed complexity is a major hurdle, as troubleshooting across various services can become difficult when the components interact with each other. To successfully navigate these challenges, a strategic and thoughtful approach is necessary when you're looking at modernization. This case study showcases the successful modernization of a core banking platform at a leading financial institution, and it delivered some remarkable results. There was a 50% reduction in operational costs, 30% improvement in response time, a 75% faster deployment time, basically reduced from 100 to 25 hours. There was a 40% increase in developer productivity. So basically, these outcomes highlight the significant business benefits that your organization can gain as part of a well-executed modernization. As someone who's gone through this exercise myself recently, I'd say begin with small pilot projects to demonstrate the value of modernization before you go full throttle on scaling up. Focus on training, focus on upscaling your team to make sure that they have the skills and the resources that are needed for this ongoing learning. Make sure you prioritize your security embedded in every stage of the process and ensure that you have compliance throughout this process. Lastly, implement strong observability and monitoring to continuously refine and optimize the transformation based on data that you collect from the real world. Now, let's look at some of the future trends in .NET and microservices. There's serverless architecture, particularly function as a service. This is becoming a new standard due to the cost-effective pay-per-execution model. We have machine learning, which is now being integrated into services, powering intelligent applications with predictive capabilities. There's edge computing, which is bringing processing closer to data sources, thus minimizing your latency for real-time operations. Also, WebAssembly, which is delivering near-native performance in browser, unlocking new distributed possibilities for certain applications. Lastly, digital transformation is not just a one-time event, but an ongoing journey of continuous improvement. By embracing modernization, organizations can stay ahead of the competition and seize new market opportunities. It's essential to build adaptable foundations so that even with emerging technologies and newer future trends, you will be poised perfectly to evolve with them. Staying agile and committed to constant improvement will make sure that with rapid changing business environment, your organization is in a position of success. And with this, I conclude my talk on transforming legacy systems with .NET and microservices to build a more scalable and agile application. I hope you enjoyed this talk and will consider some of these talking points when embarking on your own journey at your own organization. Hope you have a wonderful rest of the conference. Bye.